Welcome back to the Aerospace Executive Podcast. I'm really happy to have one of the leading industry experts with me, Kevin Michaels. Kevin is a principal, founding partner of Aerodynamic Advisory up in Michigan. And we sat on a panel together down at Corporate Jet Investor a couple of weeks ago in Miami, and he brought up some fantastic points about aerospace supply chain. So, Kevin, good morning. How are you?
Good morning, Craig. Good to be with you again.
Thanks for coming on. Appreciate you being here. Yeah. Hey, so let's start this dialogue with something that nobody is in their world has even thought about in the supply chain. And it's Russian titanium.
Mm-hmm.
You and I know the vast majority of titanium for the aerospace industry comes out of Russia.
Yes.
Where are we at?
Yeah, this is an interesting one. So, company in Russia called VSMPO-AVISMA. It's the largest producer of titanium in the world. It's a vertically integrated company, meaning they not only produce mill product titanium that's used in aerospace all over the world, but if one goes upstream and you say, well, how do you create mill product titanium, ingots? You really have two choices, titanium sponge or scrap titanium, which is segregated and remelted and mixed in with the sponge. And so VSMPO-AVISMA has both sides of this. So it's an enormous player. Pre-COVID, 45% of the world's titanium in aerospace, roughly speaking, came from VSMPO-AVISMA. It's used, titanium, of course, is used throughout the engine. It's used in landing gear. It's used heavily in aerostructures, especially in twin aisles. The 787 is famously a double-digit titanium airframe. Turns out that titanium is very compatible with carbon fiber. So carbon fiber and titanium are really the underpinning of the A350 and 787 aerostructures. So what's happened? Well, I'll go back to 2014. When Russia invaded Crimea in 2014, Boeing, a company that is not getting kudos for being prescient these days, did something very prescient. Boeing concluded that it needed to de-risk its titanium supply and began very quietly a campaign to wean itself off of VSMPO-AVISMA's titanium, long before the broader invasion of Ukraine. And so over a 4-year period, Boeing did do that for its supply chain. They stockpiled titanium as well. And so Boeing was better prepared than any major OEM when Russia rolled into Ukraine, 2 years ago. And now, Boeing's supply chain, Boeing can do that for its own aerostructure supply chain, but what about Boeing suppliers? Do they wean themselves off of Russian titanium? No. You're still using copious amounts of titanium for things like landing gear and so forth around the aircraft. But Craig, where it gets interesting is, so now that we've had the shock of what's happened in Ukraine, what about everyone else? And it turns out that Airbus is heavily dependent on Russian titanium. A number of the engine OEMs, Rolls-Royce, Safran, are heavily dependent on Russian titanium. Pratt and GE, for the most part, avoided it, in part because they do military engines and other things, but they kind of avoided it. But what you do have is a lot of landing gear companies, aerostructures companies, Airbus, the European engine OEMs, all find themselves heavily dependent on Russian titanium still. And so they have announced that they plan to wean themselves off of it, but there hasn't been a lot of substantial action yet, as far as one can tell. There have been announcements in the U.S. of two new mills, titanium mills coming online, one in Washington State, one in West Virginia, that will add capacity. But still today, we're in a position where if VSMPO shuts off shipments of titanium, that the aerospace supply chain is incredibly vulnerable. Mm-hmm. And even though Boeing may have been prescient, it may be that supplier to Boeing that's still sourcing its titanium from Russia that would be caught. And so there's been some stockpiling here, here and there, companies trying to do their best. But the bottom line is here we are 18 months after the invasion of Ukraine, and we find ourselves still extremely dependent as an industry, even though Boeing kind of took a lead in doing things, in its own way.
How are they able? I mean, obviously sanctions, Russian sanctions, trading in dollars. How's all this? Half your supply chain is Russian, which is trying to trade it in dollars under sanctions. How's everybody getting around it, or are they?
There are. It isn't illegal to buy Russian titanium in Europe. It's not illegal to do so necessarily. Boeing made a unilateral decision, to not buy it and announced this. They started this in 2014, but they made it very clear after the invasion that they would not buy anything, from Russia. But it isn't the case elsewhere, and so it's quite legal. One of the distributors of VSMPO is a company called Tiris, and they have a distribution arms in various places around the world. And I was just reading a story the other day where a bunch of residents in the UK, I think somewhere in the Midlands, where there's a distribution facility for VSMPO, and the local residents realized that this was a Russian company distributing Russian titanium, and they were a little bit taken aback. Yeah. Even though a lot of us industry insiders know that Tiris is a distributor for VSMPO. So it isn't illegal, but if you can buy it, if you can source it through an intermediary, let's say you have, a Chinese machine shop that's supplying you parts. Might be better if you have that Chinese machine shop buy the Russian titanium than for it to show up on your own ledger. So it remains a big issue, and it remains a vulnerability point. And Craig, the one other thing I would say is that if we were not in a period where twin aisle production was dramatically suppressed, right, because of everything that's happened, what are we making, 3 787s a month, and like 5, maybe 6 A350s a month? Yeah. If we were in a period of where we were in the late 2010s, this would be devastating, absolutely devastating, because titanium demand is suppressed. We're in a suppressed environment. We've lost a lot of the supply, and that's caused great volatility. But my goodness, if we were producing at those high numbers, it wouldn't be possible to do so.
What about military aircraft? I mean, we're still pumping out. There's a trash load of titanium in the military side of the house. There
is, and I think for the most part, certainly on the U.S. side, I think U.S. ecosystem has sort of avoided Russian titanium. I'm not sure the same can be said of the European ecosystem and the aircraft they're producing there.
Interesting. And along the same lines, though, we have you mentioned high strength steel. Is clogging up a supply chain too. What's up with high strength steel?
Well, it turns out that this is a real surprise, because we weren't talking about this a few years ago, but we are now. And it is, steel has emerged as a real bottleneck. If you want high strength steel, 15.5, 300M, other standard grades that are used in bearings, gears, shafts, applications requiring very high strength. You're dependent on this sort of steel, and it turns out now that if you want it, you might be looking at a 2025 delivery. If you order now, 18 to 24 month lead times, and it is sort of one of those linkages below the scenes that is causing the aero engine supply chain to have such difficulty. and maybe some parts of the aftermarket as well, is high strength steel. How can we possibly get to those types of numbers of 75 A320s a month by 2025 and mid to high 50s of Boeing, without this? So it's 18 to 24 months or more. There have been some failures in that segment and some underperforming companies, and then labor is at a root cause as well. And it turns out that where a lot of these steel mills are, they're places where it's hard to recruit labor. They are not in the garden zones of the supply chain. Craig, I always joke around in the world of raw materials. There's like a social hierarchy. You go to like a carbon fiber pre-preg place, and you go to the company cafeteria, and you might have sushi there, and everyone's wearing khakis and getting along well. And you go to titanium, and it's a step below that. Maybe the food isn't as good, the furniture isn't as nice, but you get a decent meal. You go to a steel mill, and you'll have surplus World War II furniture there. And I can assure you there isn't a sushi chef anywhere within 50 miles. So there is this, I'm being tongue in cheek, but there is a lot of truth in this. And a lot of these places where the steel mills are, it's just not where you're going to be able to recruit labor, and especially younger labor, to come and work. And then the certification barriers are enormous. And you couple that with underperformance, some financial failures. I won't get into all who's doing what where, but it's become a big bottleneck.
Well, you think about I'm getting towards, I've got a few decades behind me, and I look at, the times when I was a kid, Billy Joel saying, we're living here in Allentown. It's not because the steel industry was a bastion of labor, peace, and love. And, it's tough. One of the toughest industries. China, Chinese steel coming in, Japanese steel coming in, a lot of it, it's like pilots. You think about the stuff that happened 20, 30 years ago, or you're feeling the effects now. And I know
there were a lot of capacity cutbacks, some as a result of the crisis, but some were just decisions that were made. And I think a lot of the steel, mills are loath to add capacity, and are letting the prices rise and lead times extend. And so something we weren't planning on, something we wouldn't have been talking about 18 months ago, but it's kind of emerged. But, for those bottlenecks, some of them have gotten somewhat better. Had we been speaking a year ago, we would have talked a lot about electronics, and it was especially affecting the defense side of the business. And there was famously a shortage of fab capacity, and which is holding up the auto industry, and hundreds of thousands of cars and Ford F-150s parked because they can't get chips. And in aerospace, something like 1.5% of the world's demand for chips is aerospace. So we're definitely a third tier customer. So we were having a hard time getting the attention of the foundries. And but now it sounds like that situation, it isn't completely over, but it's improving. It's getting better. Forgings and castings are another area that we spoke about, and they were issues before the COVID crisis and the MAX shutdown, and they are still issues today. And very famously, we have a duopoly in investment castings, really, between Howman Precision Cast Parts and a couple other very capable suppliers, a company called CPP and another called Doncasters, that are knocking on the door and really trying to get into that upper tier of suppliers. But there remains just enormous problems, capacity issues there. And Craig, it's been compounded by the fact that the configurations of the LEAP and the geared turbofan have been changing as they've been dealing with teething issues. So, and by the way, these investment casting facilities are also in locations where it's hard to recruit labor. So you're seeing more investment in automation and other technologies that, that might help offset that. And help to address the bottleneck.
Yeah, no, and I know a lot of rocks get thrown at, how could this happen? And it's like, well, COVID came, and then Russia came. It's now you look at people, Israel, major supplier of electronics.
Mhm.
It's easy to throw rocks at the companies when you really don't understand what's happening below the surface. And when
Yeah.
you're talking lead times, 2 years for high strength steel, or half your supply chain. Going back to you said, hey, source titanium through a third party. The reverse is happening is that the feds are cracking down on the aftermarket parts companies.
Mm-hmm.
Because a lot of that actuator getting sold to maybe China Southern Airlines or is ending up in Russia. And how do you prevent, they're doing, they're sourcing their stuff through third parties too. So
there's a lot of
kind
leakage out there. Yeah. On the whole subject of Russian aircraft and how are they still operating? And it's hard to enforce that.
It's a constant cat and mouse game that, I don't think it's going to ease up, but we were talking, like I said, we were down in Miami and you talk about all the challenges of the supply chain. You put this, and oh, by the way, now everybody, the ESG thing is coming in to play, especially in Europe, where suppliers have to talk about how much carbon they're pumping into the atmosphere.
Yes, that's right. Yeah, we're seeing ESG. It's the industry's focus, rightfully so, has been focused on what's called Scope 3 emissions. And for those that don't get into this too much, Scope 1 emissions are what are the emissions that are created by my building a product? So if I'm building an engine or a pump or an aircraft, what are the emissions required to build that aircraft, including sourcing things in my supply chain and transporting things to my final assembly facility and all of that good stuff? Scope 2 emissions are, what are the emissions that come from the energy required for me to build this aircraft or engine? All right, so do I have green sources? And then Scope 3 emissions are, what are the emissions that are generated by this product that I create? Meaning, when I build this aircraft, what are the emissions it creates? And so as an industry, our focus has been on the Scope 3 emissions, right? As it should be, because aircraft, are out there a long time and they are carbon intensive machines, in operation. But in Europe right now, growing number of the big publicly traded companies, but it's going down to smaller companies now are required to put out what's called a non-financial report, which is a report, amongst other things, of ESG goals. And so one must document sort of as best they can, what are the emissions created by my enterprise of what I do. And it's interesting. I delved into the Airbus non-financial report. One of the little nuggets I found in there was that 20% of Airbus's emissions are just from transporting things to and from their factory. Airbus has this far-flung, their supply chain approach is very, they have final assembly facilities in 5 countries today. Obviously they're building here in North America in Mobile, Alabama, and in Montreal. But you take something like Mobile, Alabama, where you're making A320s and 220s, the wings and the fuselage and all that, they're sent over in a ship from Europe. I mean, it's assembled in Europe, the raw materials sourced all over the world. Raw materials fly into, if you take wings, for example, they fly into the British Midlands. The wings are assembled there. They're put in the Dream Lifter and flown over to Hamburg, where they're assembled, they're assembled, and then they're put on a boat and sent to Mobile, Alabama, and pulled off the boat and then sent to the final assembly facility. And I wrote a column on this recently, Craig, and it just seems like a pretty archaic approach to a supply chain to me. And, and kind of think it's time for Airbus to step up and create more of a modern North American supply chain. I mean, it is a perfect time to do so because they're capacity constrained in Europe. Energy costs are high in Europe. Airbus needs to hedge its currency and its supply base wherever it can. And here you are in North America now, and you have a lot of suppliers in a world of hurt that would kill to have the opportunity to support the A320, for example. And in the broader sense for Airbus, it will give the Airbus more access to the U.S. defense market in the long run. It gives them a chance to really spread beyond the political base that they built for themselves in a much more substantial way. And it's not even a zero-sum game, because you could, in essence, say to your European supply base, you know what, we're at 55 a month right now. We're going to keep you there. You don't need to put the additional CapEx in to get to 75. We're going to do that in North America. And it could be that the Airbus suppliers come and set up facilities in North America. It could be that Airbus sources from North American suppliers, or Airbus vertically integrates. I mean, it could be a combination of any of those. But the point where I'm headed with this is that Scope 1 emissions, which are now being measured in European primes and in some North American primes, will start to play a greater role in supply chain decisions. And I think for big, heavy aerostructures, big major aerostructures components, the days of flying these all over the world. I mean, I think that in time that will change.
I think, it's, here's the challenge we have is, look, Airbus could get a whole lot more efficient with its supply chain. It's a European conglomerate and they want to give everybody a little piece of the pie. And that's just the way the company was built. And now it's probably changed. But I think my criticism of the ESG thing is it's run by the no crowd. Yeah. When I say the no crowd, it's a little bit like lifting up the couch in your family room. You're just, you really don't want to know what's underneath it. So just some things better be left alone. And it's like, well, now we got to report all this stuff. And what it is, it's just opening doors for the no crowd to talk about how we're going to make economics more difficult. It's just going to be more difficult. And every time you try to do something better economically, the no crowd comes in. And, does the pendulum swing the other way? I eventually think that people start to get sick of the and you're
starting to see some of that now. And one thing I would say, though, is on the Scope 1, Scope 3 emissions, is maybe to put this in very, our industry, the focus should be on Scope 3 emissions, not Scope 1, in my opinion. In other words, the ratio of emissions created by an aircraft over its life versus the emissions required to build an aircraft. I mean, that ratio, this is the wrong number, but it's in the ballpark. It's probably 50-1, Scope 3 to Scope 1. I mean, it's a big number, huge number. In other words, the issue isn't the emissions to create the aircraft. In cars, and I've read this recently, and so take this with a grain of salt, but with a Tesla, where does one break even on emissions? When you think about everything that goes into the battery and building the car and all that, the number I've heard is that 55,000 miles is at the point where the Scope 3 emissions that you've saved by operating an electric car offset the emissions required to create that car. Right. And then you're a net positive contributor. But electric cars require a lot more emissions to create. So aircraft, it's a different deal. Like the Scope 3 emissions overwhelm the emissions required to create the aircraft. Nonetheless, in Europe, they are doing non-financial reports, and it is something that they are looking at, and it is something that is informing their decisions. And, we'll see what path that takes and to what extent that spreads across the pond to North America. There are a lot of chiefs, a new position, chief sustainability officers in the big primes and tier ones. You'll see them. And part of their job is to get their arms around Scope 1 emissions.
Just a big lean exercise. It's just a big lean exercise is all it's going to be. It's how do we lean out the supply chain and make it, but it's once again, it's one more thing that makes your head hurt when you think
it
about
is.
it.
It is.
It's a very complex supply chain. Hey, switching gears a little bit. So your compadre, who I've got a ton of respect for, Richard Abalafia, put out his monthly newsletter. He's pretty critical of Boeing. And I think he's critical of the fact that, hey, look, they haven't designed a new airplane since 2004. They've said that they're not going to come out and do another one for another 10 years. Yeah. But how much of that is dependent on the fact that the engine OEMs are still getting healthy from COVID? I mean, you got Pratt & Whitney, which is dealing with its own issues on the GTF. Rolls was crushed in COVID because flight hours were down, and a lot of its revenues generated per flight hour. When GE's breaking itself up, and it too had the same similar problems to that Rolls had. So the OEMs don't have any money to invest in new engines. That's a huge risk sharing joint venture. Is Boeing's decision right?
In my opinion, no, it isn't right. It's to wait till and to wait to that long of a gap. It isn't right, and not to even outline much of a vision other than getting to $10 billion of free cash flow by mid-2020s, which presumably will be, if we get there, it'll be the moment probably where you see leadership change, at Boeing. But there is, Richard and I believe that there's this opportunity that is there and continues to be there for a white sheet aircraft. Now, we can talk about Boeing's balance sheet and its debt and everything else, but I think the point that one of the issues of contention is that the CEO famously said, we need 25% type savings, fuel, improvement to launch a new aircraft. And in fact, a lot of the improvement in this industry comes in a much more incremental way. And in other words, do we need this? Do we need the next generation of engines? Let's say an open rotor rise. Do we need that to launch a new aircraft? And while that might be helpful, I think our point is that no, you don't need to wait for that. You can get a second generation GTF coupled with lightweight airframe, coupled with the digital design tools and other approaches that get you a 12 to 15% fuel burn advantage and get the aircraft out to close this gaping hole in Boeing's portfolio, which we all know about. It's the NMA gap.
Yeah.
And it's interesting. Delta Airlines, just their maintenance costs are up 35% this year over last year. And one of the reasons they cited was the fact that they're having to do heavy checks on their 757s and recapitalize their PW2000s, And I look at this and I'm like, this would have been Boeing's launch customer for the NMA had they done it. Delta was dying for the NMA. And, and here we are now, and they're going to be pouring money into a design from 1981. Yeah. 757. It's an aircraft I love to fly in, by the way. I'm a big Delta flyer. But no, there is an opportunity. And, Dr. Ron Epstein of Bank of America Merrill Lynch even went so far as to put out a hypothetical, kind of a conceptual aircraft, a high wing with an open rotor that he believes could be a very strong seller for Boeing and help to address this gap. And so I think, and not only is this an issue, but just the broader macro issue is where do the skills come from to design a new aircraft? Do those just completely atrophy? And given the fact you haven't done it since 2004. So Boeing's in the business of building and developing aircraft. It's not an aftermarket company.
Mm-hmm.
This is what it does.
Right.
And so it puts Boeing in a real pickle. And even when they get around to doing this, whenever that happens, what skills are you going to have to be able to even pull this off and execute it?
Yeah, I mean, look, what's the Max? Is a derivative of the 737, which is now what about? Yeah, it's as old as I am. It's a 50-year-old design.
1968 entry into service, right?
So 1968 entry into service. I got to think the LEAP 1A, 1B engines, they probably have some margins in there that they can increase thrust. They've got some. Yeah, you could burn them a little hotter, burn them a little. Yeah.
You could develop. The thrust requirements for something, let's say in the 180 to 250 seat range, you'd have to creep up the thrust a little bit. So maybe now you're taking the thrust up, around 40,000 pounds, but that's within the realm of possibilities. For some, for something in this range of this size range, you're probably, you're looking at probably taking the thrust up into the 40, possibly higher range, depending on how big the aircraft is. The concept that Ron is pushing is it's a twin aisle, but it has 6 seats. It's 222. And so there are design trades there. But, at this point, this is really it's an abstract discussion because, Boeing has sort of made its bed. And this really leads, you were asking about Richard's monthly newsletter. And one of the arguments that Richard makes is that, look, with Boeing's well-documented difficulties and the fact that they just sort of let go one of their most promising executives and eliminated the strategy role, the corporate strategy role at Boeing, what does the future hold for the company? Is the company preparing itself for breakup, to maximize shareholder value? Now, of course, GE right now has been in the process over many years of really moving from a conglomerate to and will soon be a pure play. GE today has the energy and oil and gas part and the aero, but that the former is a company called Vernova, and that will be formally spun out next year, and GE will be GE Aerospace. That will be a pure play. But Boeing, I would argue is Boeing a conglomerate? I don't know. They're focused on the same industry, aerospace. Mm-hmm. They have space, defense aircraft, commercial aircraft, and then global services. And, to me, Craig, on that argument, I think that space is potentially something that could be non-core. That Boeing really hasn't had a good go of it. There are parts of the services portfolio where they bought up, as distributors like Aviall and Jeppesen and others. I mean, are they core? I mean, they've been a nice financial ballast. They generated, Boeing Global Services generated free cash flow during the COVID crisis when other parts of Boeing were not. Yep. So it was welcome then. But is there a genuine synergy with the rest of Boeing? I think they've long since abandoned that $50 billion services goal that they rolled out, a number of years ago. Then it comes down to commercial and military aircraft, or, and is there synergy there? And this is where I'd say I think there is synergy there. If you go back to what we just discussed, the fact that the commercial side hasn't had a new white sheet since 2004, when Boeing does get around to doing that, where are you going to get the skills to do it? Mm-hmm. Who's launched? Who's been involved in new aircraft? Who's working with digital tools, digital twins? The Department of Defense and the Pentagon is well ahead of the commercial world in digital engineering requirements. Mm-hmm. I mean, they're requiring on the FLRAA program, one of the deliverables, which I think is coming due fairly soon, is going to be a delivery of a digital twin of that aircraft that will be flying and they'll be flying missions. They're going to be simulating logistics costs and sustainment costs and other things. And that is one of the contractual deliverables by the Department of Defense. And the last time I checked, airline CEOs are not asking for digital deliverables in advance.
No doubt.
So defense is galloping ahead on digital engineering right now.
Well, you think about it.
And I would argue that is one of the dangers if you were to break up Boeing Defense and Commercial, and they, I mean, it's hard enough to get engineers in these days, as we know. But if you let go that side of your engineering core to a separate company now, and it's only about the engineers you have on the commercial side, oh my Lord, what do you have now, especially as it relates to the ability to launch a new aircraft?
Once again, it's like pilots. The decisions you make today, the decisions made 20 years ago have created this fiasco of a pilot shortage.
Yeah.
And the same thing is if you let the engineering talent atrophy, you're not going to find a young engineer in 20 years who knows how to put together an airplane.
Yes. Here in Detroit, I'm in Ann Arbor, and this is the automotive engineering capital, of North America, Southeast Michigan. But you're seeing a lot more of the engineering now move to places like Mexico, and in other parts of the ecosystem. And I hear this from my friends, the industry insiders that are working on this. And, and I think some of this is just that we're not producing enough engineers in this country. So that's part of it. But part of it is economics, where, you can get an engineer in Mexico that can do a fine job at a fraction of the cost. And we've seen this in aerospace, in engineering, India famously on software and IT. Here's a fun little fact. I mean, we're the greatest concentrations of aerospace engineers in the world today. And one of the top 3 cities is Bangalore, India. And I don't have the exact current number, but I know that, it was 25,000 engineers at least about 7 or 8 years ago. Today, I bet it's 30 or 35,000. Enormous, but it's software. It's 100 engineers here, 1,000 there, 500 here. Boeing is dramatically expanding its presence, in India. I think it has 4,000 in Bangalore right now. Honeywell has been there for a long time and has moved a lot of its engineering to India. GE has a lot going on in India. So, but we're seeing, this next phase of globalization on engineering play out as well.
And you think about Boeing Defense, we're not making any more C-17s either. Eventually, those got the dog snot beat out of them in Afghanistan. And the Air Force is doing all they can to keep them flying. And eventually, you think about the engineering that goes into an airliner can also go into, new heavy lift, cargo.
Yeah, and in the defense side too, it's not just that we have new programs, let's say like the B-21 or FLRAA and so forth, but you have the steady stream of smaller programs. Many of them are black programs that give smaller companies and large companies the chance to hone their digital engineering chops. And especially, again, if it's a requirement of the customer that you have digital deliverables and you're willing to pay or help fund the development of those digital tools and processes, right? That makes a huge difference. And again, I think it's why if you're looking for best practices in digital engineering and digital twins and Industry 4.0, use whatever terms you want, I think one should probably be looking at some of the defense primes.
Yeah. Do you think Boeing gets broken up?
I think Boeing gets reshaped, but not broken up. My colleague, Richard, we don't agree on everything. And he might make a stronger case that they're preparing to break up. But I think breaking up the commercial and defense side of the aircraft business in particular would be, I think it would be a mistake at this time for the reasons I've highlighted. But it's not to say that space or parts of that global services portfolio, are not worthy of revisiting. What's how core they are and where you go from here.
I agree. I still anticipate opening up my Wall Street Journal, which I read every day, and reading that Ackman or Elliott Management or Pershing, one of those activist investors has been assuming a large stake in Boeing. It's relatively a cheap company.
Yeah.
From a price to earnings ratio, it's comparatively, it's a pretty cheap company. And I suspect one of these folks has been, accumulating shares, and the hammer will drop. Maybe I'm right, maybe I'm wrong. I don't know, but I keep expecting that to happen. And
the other interesting OEM that has been, I think a lot of us have been watching is Rolls-Royce, and amongst the engine OEMs, and as you know, Rolls-Royce famously bet on twin aisles, and got sold their share of the V2500, and then had this Indianapolis arm, the old Allison, right? It was kind of, I wouldn't say an afterthought, but compared to the sexy things Darby was doing, the development of the Trent and everything else, and the evolution of the Trent over the last 25 years, you didn't think about Indianapolis very much. And so Rolls-Royce brings in a new CEO from outside the industry, is on kind of death watch. Market cap falls to something like $6 billion at one point. And a lot of us were wondering, can Rolls-Royce make it to the other side of this crisis? And but it turns out that Indianapolis has had this great run where they won the B-52 re-engining. They won the FLRAA propulsion. So they have had a very nice run. And, and Rolls-Royce, meantime, is just leaning everything out. Rolls-Royce had a final assembly facility in Singapore, which was going to be its biggest final assembly facility for Trent engines. They shut that down during the COVID crisis. They shut down a production facility in Germany, and they've kind of retrenched on the final assembly side, to the UK and to their two production facilities there, one civil, one military. That's really where they've retrenched, as well as what they make in Indianapolis today. But it looks like they're in better shape now than they were a year ago, but there's still a lot of hard decisions to be made there. And, for many years, a lot of people said, gosh, could Rolls and Pratt ever merge? On paper, it makes a hell of a lot of sense. Politically fraught with challenges, culturally fraught with challenges. I think that's off the table right now, just given everything that is going on at Pratt and RTX and all the rest. It's not in the cards on that. But Craig, in the long run, we were talking earlier about sustainability, and the engine OEMs are in this real pickle, because we're in this world now where there are, not only is the core business kind of under a lot of threat today because of supply chain difficulties and other things, the costs, whether it's the Trent 1000 issues or the LEAP issues or the turbofan issues, which just dropped a $7 billion surprise in everyone.
Right.
But then they need to stay invested and stay in the game on sustainable aviation fuels, on electric, on hybrid electric, on hydrogen combustion, on maybe hydrogen fuel cells. And it's not to say that they need to put all their chips on every one of these bets, but they have a very high stakes game that's going on right now. And it's not too dissimilar from what the automotive OEMs went through when we first came out. Remember, years ago, we weren't sure what the right architecture would be for cars. Would it be all electric, or which was sort of Tesla's vision, or would it be the Toyota vision where it'd be hybrid, right? And we found out that for cars, at the end of the day, the winner is all electric. But it's forced the automotive OEMs to share technology with each other, because it doesn't make sense for every one of them to pursue all these technologies. And I think we're in that world right now with engines, where if you think about Pratt, GE, Rolls, and then Safran. And Safran and GE have been very closely tied at the hip and almost acting like one company. An incredible joint venture, greatest partnership in aerospace history. The CFM partnership between the two of them, maybe one of the greatest in industrial history, has worked really well. But how does one keep their bets on the table for all these other technologies at the same time that your core business is under threat? It's a lot to ask for. And that's why, in the long run, I still really believe you're going to see more consolidation in the aero engine space. And if you broaden the discussion to include people like Honeywell, which have a small engine and APU business, in this, so you've got Honeywell, Safran, Rolls, GE, Pratt & Whitney / RTX. I think a decade from now, at least one of those four will be merged into someone else.
Yeah, I agree with you. And that's the reason you don't fire your chief strategy officer.
That's the reason you don't fire your, yeah. And, on that point too, Greg, maybe something worth mentioning, and we've done a lot of work, for some very interesting clients looking at, the pros and cons of these technologies and what's likely to develop when, and quite frankly, what's happening at different size category of aircraft, because you can't talk about this in generalities. But yeah, it's very clear that if you're looking at like 9 seats and below, possibly slightly bigger than electric, you can have an electric aircraft, that can be decent over the next 10 years, something like an aviation, let's say. Yeah. But you're very much limited in that size range. Mm-hmm. And to get above that, you're probably looking at something that's hybrid. But where most of the emissions take place in the jetliner world, the only near to medium term solution that's going to make a difference is SAF, sustainable aviation fuels. Mm-hmm. There are things we can do at the margins and air traffic control and routing aircraft more efficiently, and electric tug and things like that. But it's really going to be about SAF for the next 15 years. And I think it's 97% of all emissions are produced by aircraft that are over 50 seats. So we can talk all day about electrifying small aircraft or, advanced air mobility being some kind of a green solution, which it's not. But, right. But that's where the emissions are. And SAF is the ticket in our view. It's the lever that we have to pull over the next, certainly through 2040.
I agree with you there. So, hey, look, we've been on for about an hour. Will you come back and do another one?
Be delighted to do so, Craig.
I could talk about this all day long. It's been a fantastic conversation. How do people get a hold of you?
People can get a hold of me on the website, aerodynamicadvisory.com. I'm on LinkedIn as well. You can find me there as well, Kevin Michaels, and I'm at Aerodynamic Advisory. And
you're all over Aviation Week. And yes. Your articles in your editorials in Aviation Week are always fantastic and spot on.
Well, thank you. I appreciate that. Thanks, Craig.
Thanks for coming on, Kevin. I hope you enjoyed the latest edition of the Aerospace Executive Podcast. You can reach out to me directly, Craig at NorthstarESG.com, or check us out at www.northstaresg.com. You can subscribe to this podcast on iTunes, Stitcher, Podbean, or on YouTube. Just do a search for Aerospace Executive Podcast. Thanks again. I'm Craig Piven.